Okay, so I want to look at a couple of examples here out of the McGraw-Hill textbook today. I think there's a lot in them that we want to make sure we've got in case it needs clarification. So these are on page 398, just the two examples that are right there. I thought I'd just pull them up and kind of go over them instead of doing two other similar questions in case you wanted to look at these later on. So the first one, log x minus 1 in brackets minus 1. First thing you want to recognize is anytime you're doing a question like this, you want to treat it like you would have any other equation. If I was trying to isolate x's, for example, in a polynomial, I'd get all the x's on one side and so on. So the definition, or the descriptions here are pretty good. Isolate the logarithmic terms on one side, and then we have some rules as to how we can deal with something that looks like the second line here. So again, initially good explanations. We go through sort of what we've seen recently. Two exponents, two logs added together. We can multiply the terms. And then basically in here we have something we can work with from before, multiply it through. At this point, I think we can probably do something a little differently. Certainly what's done here is fine and is correct, but I think first instinct for most people might be a little different. So instead of this line specifically, and it really is just this one line, from here, what I would tend to go to is I have a log base 10 of this term equal to positive 1. Okay, so I guess we could maybe write one more line in here. So do the expansion of the binomial terms, keep it equal to 1 for now. So that's kind of, I think, what people would tend to go to. And then this is just a log written in sort of standard form. We have a base 10, the exponent is 1. So I would tend to go to 10, the base, to the exponent 1, equals x squared plus x minus 2. Now you can see obviously that that's exactly the same line as where you end up here as well. But I think this change, going from the number 1 to recognizing that it's log to the base 10 of the value 10, is a step that people would probably struggle with to some extent. And the big thing is, if this number were a number that didn't work very nicely here, it might be, well, I shouldn't say that. I think this is going to be more confusing to people than just trying to rewrite it. So I guess my suggestion is just, if you want to make sure, if you're going to have less trouble by just rewriting it, do it that way. Obviously we end up at the same place anyways, and from there we can kind of continue on and finish up. Everything here should be familiar. We've been doing that for quite a while. The key though is at the end, when we get our two answers, we do have to verify them. And for our class, I won't be a stickler, as I haven't been maybe all year, and maybe I should have been more of a stickler. But for those of you going on to post-secondary and doing some sort of work in math at that point, you want to make sure you're a little bit careful as to what you write in verifying your solutions. And so, looking back at the original equations, necessary to reject x to the x minus 4 as an extraneous root. So that's something you should recognize. When you put negative 4 into our original equation, part of that original equation is log of negative 4 minus 1, which is negative 5. And so the one thing we have to be careful of is we don't want to test this value the way we would have normally in the past. Okay, so if we're testing value to see if does the left side equal the right side, our tendency is to write left side is equal to log x minus 1 minus 1. Excuse my writing here. This is how we would have started this before. We would then plug in log negative 4 minus 1 minus 1. And then we would try punching into our calculator and say, oh, that doesn't work. But again, just the fact that I've written this line means I've written something that is mathematically impossible. And so we shouldn't be doing that. And again, certainly next year, those of you that are going to be taking any math involving logs, you won't want to be doing that at that point in time. So in this case, we sort of probably can see right off the bat that -4 is no good, and a statement to this effect is fine. -4 is no good. And it sort of explains that this is why it's no good. You don't necessarily have to do that. You know, a quick statement, x cannot be -4 since we can't have negative logs. And then x equals 3 is fine. Now, you should be verifying, I suppose, that it worked, but if you know that it worked, then that's okay. Now, as we move on to the second one here, we'll sort of see it a little bit better. Same comment on this line right here. You know, my feeling is a little bit easier solution at this point is simply to go to the base is 10, the exponent is 2. That's going to be equal to x squared plus 48x. And of course, it gets us right back to where we were anyways. So whether you choose to just to recognize this as log of 100 at that point or something, or just kind of make this move, my feeling again is if the log is not a base 10, then probably this is what's going to work better for us most of the time. Again, absolutely nothing wrong with what was done though. So the rest of it, I think we can follow through pretty easily. I guess the one thing to sort of hear is remembering that the cube root of something has an exponent of 1/3, and obviously for the logs we would like to eliminate that square root. We've seen that in a little bit of the work we've done recently. Once we have an equation, anything that you used to use before, addition, subtraction, multiplication, division, anything you would have done with an equation with a polynomial, you can still do here. We can always, if we have two things equal, do the same math to both sides. So whether it's taking the logarithm of the log of both sides, or squaring both sides, or in this case, simply multiplying both sides by 3 to eliminate the fractions, all those things you've done in the past, you're kind of able to do as well now if they help. The key here, though, that I want to take a look at was sort of how they handle dealing with the roots down here. We have to check to make sure that both of these solutions are valid. Last time we saw, obviously, one of them was not. And again, just sort of being careful, it sort of explains that for a valid solution, the argument in green must be positive. So we should be checking that that term is positive before we stick it into the log. You know, if I write log of this and it turns out this is negative, again, I'm writing some math that's just not valid. And so going through it, you see that they just verified, first of all, does the -50 give me a valid solution here? It absolutely does. And so that means it's okay to write that the left side is equal to this, because it does equal this. It's not, this is not some value that I'm not allowed to work with. And then we work it out, find that it's 2/3, which matches with our original equation. So the left side now is 2/3, the right side was always 2/3. And so, so it equals the right side. So this is a valid solution. In the second case, x being 2, now you can eyeball this as well, right? I recognize right off the bat that if I'm squaring a value here and I'm plugging in a +2 here, I get a positive value. So as long as you know that you're not going to have a negative value in here, you're able to get to the left side being whatever it is, solve it as you need to, and of course you find that it's still equal to the right side. But the key is that we just shouldn't be writing this line right here if there's any chance that that ends up being a negative. So again, mostly just a formatting thing. For our purposes, I probably won't worry about it because it's sort of late in the year, but certainly in the future you'll have to worry about it. Okay, so the big keys going forward, you've learned a few new things with the log laws. and applying those. And of course, any techniques, anything you've done in the past for solving equations, still valid and may be required for you to actually get to the answers you're looking for. I will post some solutions if anybody has specific questions. So if you run into some that are tougher, email them. I'm probably available most of the day. Not necessarily, no, it's bad, I'm gonna stop it here.